Hello everyone, this is Chris Couture. Welcome back to my channel. Today we are going to learn how to write a Python program to calculate nth Fibonacci number in O log n time. So a typical implementation would normally take O(n) time complexity, as you would have to loop through 1 to n. Today we are going to find out how to leverage matrix multiplication in achieving O log n time complexity. A key observation to make here is that if we were to consider this 2 by 2 matrix M depicted here, and if we were to raise it to the power n, we would get a 2 by 2 matrix that looks like this. And this can actually be verified very easily using standard matrix multiplications. So it all boils down to finding the n-1th power of this matrix M, so that we end up with the term Fn in the cell 0, 0 of the above two-dimensional matrix. Now the real advantage of this is calculating powers of functions or numbers is actually much faster when we start with powers of 2 and squaring each resulting term. For example, if we were to calculate m to the power n, we could start with m squared, and we could square this to get m to the power 4. And we could square that to get m to the power 8, and you could square this to get m to the power 16, and you could keep squaring each matrix, the resulting 2 by 2 matrix, until you reach m to the power n. And if you look closely, it would approximately take log n steps to get to m to the power n, starting with m. So one thing to note here is that we may not always arrive at n exactly at n by taking powers of 2 unless the number n is a power of n itself. So instead, a better approach to the above process would be to use a top-down recursion, as we shall see in this video. So let's go ahead and start by creating a method to calculate the product of two matrices, specifically two 2 by 2 matrices, which we're going to be using to calculate the powers of n. This product right here will give us the very first cell in the matrix. This will be our cell 0, 1. Okay, so here are our the values in the 4 cells of the resulting 2 by 2 matrix. And as we can see, the value of the resulting matrix F is getting updated here. So we're updating the value of F in place after we multiplied with G. So let's go ahead and implement our top-down recursion process to calculate the value of f raised to the power x. First, we start with the base case of this recursion. And let's go ahead and define our 2 by 2 matrix that we're going to start with. So we are starting with f and raising it to the power x divided by 2. Note that we are actually taking a floor of x divided by 2. This last step right here is to make sure that if x were to be an odd power, we would have to multiply one last time to get to f to the power x. And that's it for the recursion function that calculates f to the power x top down. Let's create a method to actually calculate the Fibonacci, the nth Fibonacci number. So as we had looked at, we were supposed to take the n-1th power so that the first cell in the 2 by 2 matrix would give us the nth Fibonacci number. So let's go ahead and test this out.
I'm ready.
Okay, so the value of nth Fibonacci number when n equals 9 is 34. Let's just verify that it's correct. There's some rounding going on here, but it looks correct. I hope you like this video. Please don't forget to hit the like button if you do, and subscribe to my channel for more related content.